Solve a radical equation with a single radical. To solve a radical equation, first we want to isolate the radical on one side. Now you can see here the radical is already isolated on the left side of the equation. So we square both sides. The square of a square root is simply the item that's underneath, right? These are inverse operations. So we square both sides, we are left with x minus 2 equals 64. Now we solve for x. So we isolate the variable by adding 2 to both sides, so x equals 66. Whenever solving equations, we always want to check our answer. So we substitute 66 into the original equation for x. 66 minus 2 is 64, and then the square root of 64 is indeed 8. Let's do another one. Let's solve the square root of 3x minus 2 equals x. Well, the square root is isolated on the left side, so we are ready to square both sides. That leaves us with 3x minus 2 on the left equals x squared. We now have a quadratic equation. So we want to get that in standard form, meaning have one side equal to 0. I'm going to subtract 3x and add 2 to both sides to give us the equation in standard form, x squared minus 3x plus 2 equals 0. Now I can use any of our ways of solving a quadratic equation. I could factor, I could complete the square, I could use the quadratic formula. The easiest way here is to factor. So we have x minus 2, x minus 1 equals 0. Set each of our x binomials there equal to 0, and we end up with two solutions, x equals 2 and x equals 1. But don't forget to check. So we go back to the original equation and we say, well, what if x equals 2? So we substitute 2 into both placements of x. Now let's simplify inside the radical. 3 times 2 is 6, minus 2 is 4. And we do know that the square root of 4 is 2. So that checks out. Now let's go to the second solution, which is x equals 1. We substitute in and simplify. We end up with the square root of 1 equals 1. Both of these solutions make the equation 2, so true. So we have two solutions. Let's do one more that's not quite as nice. We have the square root of x plus 12 equals x. We square both sides. That gives us x plus 12 equals x squared. Now let's get that into standard form. So we have x squared minus x minus 12. I like to put things on the side of the equation where the quadratic term is positive. Just makes the whole solving piece just a little easier. Now I can factor that, x minus 4 and x plus 3, and we solve. X equals 4 and x equals negative 3. But don't forget to check. So we go back to our original equation and we substitute in those values. When I substitute in 4, I get the square root of 4 plus 12, which is the square root of 16 equals 4. And yes, that is true. Then I substitute in negative 3, and I get the square root of negative 3 plus 12 equals negative 3. This gives us the square root of 9 is negative 3. In this case, that is not true. When we are solving, the square root of 9 is positive 3, and therefore negative 3 is not a solution. So for this last equation, we only have one solution, and that is x equals